start recording. Okay, let's see. So we've got our happy little thingamajig here. I don't know why you decided to break execution there. Maybe I've got a breakpoint somewhere. I must do. But we were fiddling around with disassembling the thing. Let's go look at debug Windows breakpoints and see. Huh, that's odd. I don't know why that was pausing execution, but it was. We'll rebuild just in case. So we were just having a look at our multi-string thing. So here we are passing a string into item, and then it turns into a multi-string, and then it calls the actual version of item. And what we determined was constructing this multi-string, which is just a wrapper around an object text, an object pointer, and then making a call. We determined that that was completely inlined. So if I go to user interface and I hit pause, we find that on the disassembly, it's just moving the arguments where they need to be, finding the entry in the virtual table and calling it. So that's what we went through yesterday. So you feeling up to speed with that?
Yep. I mean, there's still quite a lot of interesting things in there, but yeah, I recall.
Okay, so what we are going to do, you remember that I said that we were going to make all of our multi-string stuff run through, hang on a sec, just shut my door. All right. We're going to make all of our multi-string stuff run through these properties, so that we can modify these things. So,
right.
And you did make that change, so we're all good on that side. So we'll come back to that shortly, because the thing that we want to look at is, okay, we made this change when we're putting strings into these calls. What happens when we actually then go and need to extract those strings? So the method that I want to look at is internal getid. So this, because this one is so simple. So it's basically, it's just calling isString and then it's doing the cast. So let's stick a breakpoint on that. Well, let's actually run, let it JIT all the methods that it might need for that. And then we will stick a breakpoint on it. Ah, yes, because you repaved this machine, you need to make adjustments.
So suppress JIT is off,
Yep.
step over is off, just my code is off.
Mm-hmm.
And is that all?
I think that's all.
Okay.
I think that's all.
Good.
Okay, so if we then go ahead and run that, we reach that breakpoint. We should be able to go to the disassembly, and we'll see. It might actually be different in your version, because you've got a different version of Visual Studio, but it looks pretty similar.
Still can't zoom worth the darn.
That's all right. We can sort of get a rough idea. Like, anyone watching this in HD might vaguely be able to see what it says. But here we have, it's like, we're just going to scan through the code for this. And what we find is like, all right, we pushing our arguments, we're manipulating the stack pointer, moving stuff around, and then we're doing a JE, which is a jump if equal.
Mm-hmm.
Then we're, so test, unfortunately I don't have my reference up on the other monitor because my other monitor is stuffed, but test, I believe, is that testing for equality or something? I can't remember what test does. Or is it test if it's 0? Anyway, damn. I think it's just test for 0. Or is it set a flag? Anyway, this shows how much I actually know off the top of my head about assembly, which is not enough to be fluent in it. But we have test jump if equal, compare jump if equal, and clear again obviously is the XOR, and test jump if equal. So already just this if text is string line, which we can look at as like text is string is the code. It does 3 conditional jumps, and then when we go to cast it, we've got another jump if equal, another jump if equal, and then a couple of method calls, one of which hasn't been jittered. So and then on the other branch we also have jump if equal, call, and I'm guessing that this one might be the thing that throws an exception if you get the wrong type. So we've got some code that's never going to actually get called, but it's there. So hopefully you can see that this is a lot of code and there's a lot of conditional branching. So it's probably going to be quite inefficient.
Mm-hmm.
So while while it costs nothing to do this step, we've added a whole lot of cost down here. Make sense?
Yep.
So that's the reason why I wanted to put everything through the this business, because we can actually now go in and try something different and see what that does. So if you break out of execution, we can try this. It's like, well, what was all of that stuff? It's all jumps just to look at the type of this thing and then do casts on that thing, depending on what the type is.
Right.
So what thoughts do you have about how we could simplify that? So I've just commented that out, so we can try different ones and compare them. So I'm just going to copy the whole class, be a bit lazy. I mean, yeah, that'll do.
Oh, you mean just specifically just inside of multi-string itself? Like
yes.
Not in the code, not in the usage of it?
Well, I mean, if you can think of a usage thing to do, like here,
well,
then maybe we could do something there. But like we're probably, if we can make the change only within the thing, it's very object oriented. It's like, well, this is the public interface. Can we change the implementation without modifying the interface? But by all means, like, it's our interface. We can modify it if you have a good thought on that.
Not really. I mean, I think my initial thought is kind of knee jerk, and it's kind of like trading off some of the the whole point of this was to ease the developer pain of having kind of like a method for every instance type.
Yeah.
Like, we have 3 internal get IDs right now.
Oh yeah.
Obviously, if we deleted one of them, the one that has the multi-string, we and only refactor the rest of it. Because the internal get ID is like a pretty hot path.
Yes.
Like, maybe we'd say, okay, well, let's not do anything fancy for that one. Let's just do straight up call the already known type version to get rid of the is string branch, and the extra jump to the multi-string version. But
I'm
that's probably not what we're looking for.
I'm not sure how that would work. Like, I don't understand how.
Well, just whatever calling the multi-string version would just. Oh yeah, we'd just be moving that all the way up.
Yeah,
you'd end up killing all of it. Yeah,
you're not actually changing it. So
no,
exactly.
No, you're right. Okay, I mean, okay, one I no, that wouldn't work either. I was thinking maybe this is a way to cache, in a sense, the is string call, so we're not always checking it. But that wouldn't work because we're always allocating a new multi-string struct because we're wrapping. So is string is going to always be called. anyway, so that doesn't work either.
Right.
I mean, if it might, no. String builder has an array of buffers in it, so getting rid of string and using the internal buffer of string builder, it's probably too complicated just to get rid of one pathway.
Well, it sounds like that option is one that we have discussed, and that is you take you take all of your string paths, and immediately, as soon as you get a string, you copy it into a string builder, which is not a completely ridiculous suggestion, because it gets rid of all of the straight up string paths. But then, performance wise, you're doing a copy everywhere. And already I suspect that the couple of jumps that don't require copying are going to be faster.
Right.
Call coming in, damn it. Hopefully that's not important. All right. Bad time to call, buddy. Yeah. Well, because I don't have my contacts, so I have no idea who that is.
Oh wow, today's just a fun one, isn't it?
Yeah, it's
comedy.
Going very well. That's fine.
Okay, so okay, I mean, if so, this is kind of one thing I'm thinking of. Like we have, for example, like the label call in the UI system is wrapping a multi-string. Oh no, I'm doing it again. I was thinking, okay, well, if we have multi-string and like we're calling multi-string by ourselves, like we are the ones calling it, and we know that it's being called from a string method. Maybe in multi-string in the constructor no, that doesn't work. Sorry, because it's a union. I was trying to think. Well, we can just pre-initialize the string call, but that doesn't make sense because, like, then why have a union struct anyway? That way, we could just we could set the isString to true when it's a string, and leave it false when it's a string builder, but then again, you'd still be checking it, so it makes no difference.
Well,
it might though, because this call is more expensive, right? IsString has got to be more expensive than a bool equality compare.
So that's I was about to say, why don't we go down the caching branch, because that is what that is. You are essentially caching the result, and seeing as you know the result, you don't even have to calculate it.
Mm-hmm.
So, I mean, let's go down that. Let's go down that road if you like. How about we do that?
Well, I'll just make this not a property for now. I don't care about naming at the moment.
Yep.
And then just say isString is equal to false, or really have to do that, but isString is equal to true. That's it, really. That's all you need to do.
Okay. So, I mean, let's run it and
okay,
see what happens. So let's start by I'll get the breakpoint off there. Let's start by looking at the call site. Null reference was unhandled. So
what did you do to trip it?
I got my true false backwards. Right.
Oh.
I was like, that's a silly error. All right, so we'll just run it, and then we'll try the call site. So we'll have a look at what the disassembly is here. And so obviously now we're having to set something. We've got move, mood, load equals, move, mood. No, not load equals. I don't have my reference up, but that is, load address, I think. So this one, so moves whatever is in here, over here.
Load effective address.
Load effective address, yes. So what this one does is it, rather than loading what's in this address into here, it actually loads literally the address into here. And there's some obscure reasons why you'd want to do that. So, as we can see, because we've expanded out the size of this structure, now that it is no longer just a single string, single object pointer that's got the same layout in both cases. They're still inlining, but this now doing more processing because we're having to build up a thing. And as you can see, we are having to here we go. So this one here is moving information from, can't remember what DL is, but it's calculating an address on the stack here, and then it's loading into that address. I suspect the reason it has to do this is because it can't do that calculation here, so it has to do it in an earlier step. So it's loading RCX into somewhere on the stack, and then it's doing all the other stuff that it would normally do. So basically what's happened is we've gone beyond the size of what we can pass in registers for some reason. I don't actually, it shouldn't do that. So it might be interesting on your newer version of the runtime, what happens when you do yours, because it may actually be able to at least keep this multi-string with its object and its boolean. It should be able to keep that in registers. So the fact it's not is actually a bit obscure.
Oh.
Nope, that looks almost identical.
Yeah, I still have my load effective address call.
That's fine. So yeah, does it make sense what this is doing? It's taking stuff and putting it onto the stack rather than passing it in a register.
I guess because it wants to do an assignment of that pool to the property pointer.
Yep. So
in the construction.
That's not ideal. And like if we go into the usage for item, we're going to have to go into a specific version of it. Item in, let's say update. Let's see what happens here. So we call internal getid. What am I looking at? Results. Okay, so it's inlined internal getid, perhaps, which is interesting. Probably.
Haven't jidded it yet.
I don't know. Well, maybe it already knows internal getid. Let's look at my stack. So this is the thing about debugging release code, is like it's all over the shop. Like, where is my call to internal getid? Where is my syntax highlighting? Window disassembly. All right. I mean, let's just go and look at what this call is. Okay, so it is that call is to internal getid. That's fine. So obviously it's the debug information that is generated has not included that line for whatever reason. So it's just how the optimizer's done that. I'll jump back out and keep looking. So that's sort of the thing where it cares what this text is. The rest of this method, for instance, doesn't actually care what the text is. So this is basically all the same no matter what. I mean, and we could verify that, but we won't. So we'll also have a look at, before we get back to internal getid, we'll have a look at this version, and it seems to be fairly similar. So so let's see. So internal get ID. So it's looks like it's live disassembly, ladies and gentlemen. So, like, this is a bit hard to read. So, I mean, what we can do, what we often do, is here we go.
Move unaligned double quad word.
Yeah. So, do all those words make sense?
I like the word move.
So,
I guess aligned, I kind of know what that means from a buffer point of view these days. And then
that's exactly
double
what it means,
is the
yeah.
word I know. And quad word, that's like what is that, like a 4 words stuck together?
So, typically,
XMM register? I don't know what word I'm about now.
That's one of the newer registers. So that's the XMM registers are 128-bit registers that get used for things like SSE2 instructions like SIMD. Sorry, don't mind me while I shut my door again. Oh dear. All right. So basically what this is doing is it's taking a section of memory that is 128 bits and moving it there. And so a byte is obviously 8 bits. A word in Microsoft parlance, because and Intel to a certain extent, because they needed to name, when they went from 8-bit to 16-bit, they needed to name it, so that we'll call it a word is 16 bits. And then of course they went to 32 bits, so that's a D word or a double word. And then a quad word is 64 bits and a double quad word is 128 bits. So that's how that works.
Got it.
So yeah, when you're doing a whole lot of like Microsoft code, you get D word is something you'll see a lot. You occasionally see word. I don't think you see that one very much, but all over the place in, like, if you're doing Win32, you see D word.
Is there a significance of why they chose the word "word" to denote, like to say?
No, not really. Not that I know of.
I guess
it's just 2 bytes.
Yeah, that's interesting because
actually,
the actual meaning of the word "word," I just googled it.
Yeah,
it's
yeah,
like the smallest unit of language that has a particular meaning.
Oh.
But wouldn't that be a byte?
Right.
Not
okay.
2 bytes.
There is sort of a significance that, like, and it's one of these stupid backwards compatibility things. So you say that the word size of machine is basically the processor bit width. So a 32-bit processor, technically the word size of that processor is 32 bits. But of course they named, when they went to 16-bit processors, was like the word is 16 bits and they named it word. And so in that context, word means 16 bits, but because it has to be backwards compatible.
No, that makes sense.
So it's the same reason why you've got system32 is the 64-bit directory on Windows 64.
Right.
They named it that in the first place, and it had to stick. So it's that sort of ridiculous thing.
I get it. Okay, cool.
Okay, so this is our item call. So this is interesting because we've had to pass this on the stack, and so I've got this extra stuff. So let's now stop that and have a quick look at what happens if we now go back to the other version. So of course, in like a sane world, you'd be doing this, but you'd also be measuring obviously the performance Like this is sort of a micro optimization thing. And so you wouldn't be doing this all the time. So let's so you can see here that the two, let's just make a new one. Can I please have that? Can I have a different instance? No, all right, never mind. All right. Because the way moved other.
I don't think it has that. Oh, it does. Excellent.
Yeah. So yeah, the way it does it is a bit insane. So this is the one where we're not putting it onto the stack. There's our keyword, just for interest. Whereas this one, it is putting the argument onto the stack, so it gets a little more complicated. So right. You can see that we're introducing code here by also increasing the thing. So, and then if we look at internal getid, which is I'll run to that and then jump into it. So this is our old internal getid, which is, not ideal. And then we'll switch back to our new internal getid. Assembly, run the cursor, jump into it. Did I actually make the right change there? This is the, yeah. So this is internal getid. I feel like this should be this way around. No, never mind. Anyway, so this let's label these. Always got to label these. This is the one with and this is because as soon as you don't label these, it starts to get ridiculous. And this is what is it? UI draw dot item with object bool, and this is UI draw dot item with object. So now we have these side by side. We can start comparing them. So obviously, like even just looking at the size,
yeah,
by expanding out to object bool, we've kind of expanded this one fairly substantially.
Yeah.
This one is obviously less substantial, and I'm just sort of scanning down here. It's not too bad. Like we haven't added any jumps, for example, and a lot of like this move here looks like it's just expanded out to some moves through the SSE2 instructions. And over here, this is internal getid, and by the looks of it, this section here, we've managed to substantially reduce in size, but we've still got the exact same code, more or less, where we do the casts. So
it kind of makes sense. We reduced the branch of the string because we cached it. So I mean that's telling us that we reduced it there, but the casting is still, we haven't done anything to help the casting. Because that makes sense because we didn't. We just cached the string value.
Exactly.
Or the bool. Right. Okay.
So one last thing that I will one last thing that I will do is quickly gather up while we're comparing things. I'm just gonna stick a breakpoint there and grab the disassembly for that. So we've got this one as well. And I'll just grab out that. UI draw, and what's this? This is with, so obviously, okay, and then I'll do it over here. Disassembly. And this is just with object. So now I can get a sort of a rough idea of the performance across, like basically we've got the initial call at the start of like doing useful work, and then we've got over here we have like one in the middle, and like this when I say in the middle, I mean like we're pushing data through the method, and then we've got this one at the sort of at the leaf where we're actually, okay, let's undo that thing where we bundled that data together.
Right.
So where do you reckon we can go from here? Like, I mean,
well, I had a thought. I don't know if it's worth anything, but like I'm looking at, for example, UI draw label.
Yeah.
And you know, we're doing all the times we're using is string, like is, you know, calculating size, like var size equals text.string, and then measure string or measure string, you know, we're doing the method forwarding.
Yep.
That's inside a method that as a group of instructions inside the method call couldn't probably be inlined, but is there any value to moving like measure string or draw string or wherever we're doing an is string call? Is there any value in moving that into multi-string? And does that give us any chance of inlining even something like that?
Well, the thing is, the situation is because of the data that we have. So really what we're focusing on is what this data is. Like in this case, it's sort of that.
Okay. Right. Well, I mean, because if we're that worried about casting, like I guess then
because what you're saying is like, can you move this into multi-string? And it's like, well, you can move it up and down, but it's going to be the same code.
Yeah, right. I was thinking about, you know, I'm still getting my head around it. I was thinking about how like maybe this little piece of code can be like inlined if it's taken out of this method implementation, and then maybe we have less cycles. But I mean, you just gave me an idea that if we're worried that much about the casting, then why don't we just store two pieces of data?
Okay, let's try that. So I'll let you code
text,
this one up.
Yeah, so text. I have to break execution. So we'll just say we'll call this one text string.
Well, before you, I mean, I guess it's sort of not really a big deal because I've taken a copy of what the things are. But what you should do when you're doing this sort of thing is make a copy of the code, so you can like switch between them quite easily.
Oh, you mean each iteration? Yeah, I have a copy of the original, but I can make a copy of the failed experiment. Yeah,
I mean, you do the same thing when you're optimizing like by timing, but
makes sense. Yeah, so yeah, I'll make text string. I guess I'll just rename it.
Text string?
Why not? And then the other one we'll call text string builder, or text SB. And then I'll just paste this in everywhere it needs it. Can get rid of the redundant cast. Oh right. So yeah. So then I gotta. We probably don't want. We probably want to reverse the damage to isString also, because it seemed like that wasn't worth doing.
Okay. Well,
I'll go. I mean, we're doing one thing at a time, so that makes sense anyway. Get rid of the settings of the isStrings, and then we'll set text string text. Whoops, text SB. And then we have to set the other one to null in each case. It's a value type.
exactly.
This text SB is equal to all. I think that ought to do it. Oh, hold on. Oh no, it's fine. I don't know why this thing is shading out. I don't even have my fancy tool. This is just all Visual Studio. Oh well. I guess because I'm not using it. No, I am using it. That's odd.
It looks good to me. Now,
yeah, I don't. I just don't. I recognize the redundant. It says it's redundant somehow, but I don't care. Okay.
So there is one oddity that we've got here, and that is string.
Yeah, the bool is kind of dumb. We just want to say text string is not equal to null. But we don't actually need that. Well, I guess we do. Yeah, I guess we do. We do. Yeah, we do have to check.
Mm-hmm.
Oh, okay. That looks fine.
Okay. So yeah.
All right. Might as well.
Let's run it and see what we get. So let's start by looking at the call side.
Yep.
And
looks better. Way less. Well, there's no 128-bit or stacked stuff.
Well, let's compare it to what we already had.
Right, of course.
Call side.
I think it's I don't think there's any change to it, but I could be wrong.
It looks like it is pretty much. Expand that there. Do this here. So we're looking at this bit of code here, and it looks very similar to this bit of code here. Instead of
that's too bad.
Instead of moving like this one for it's a string, it's inline the constructor again for
for the value type. Yeah, the EDX. So instead of setting true or false, it's just setting null to the other pointer.
Exactly. Which, is fine. So it's about on par with this one. So we're not losing anything here, but we are losing.
Well, it's not as good. Yeah, it's not as good as the original one, clearly. But
so let's jump over to what we're looking at. We're looking at user draw item. Let's get a breakpoint on that, and look at the disassembly and compare it with the other versions. So we're looking at both this call to internal getid and the call to draw item, because we're passing this text parameter through, and we know that between here and here and here and here we've expanded the size out. So that's something that's worth thinking about, is the fact that the size of this is 128 bits, which is probably why we're seeing those 128-bit instructions, whereas the size of this is also 128 bits, because typically this will be a 64-bit pointer in a 64-bit build, and this will be whatever size it is. I think it might be 8 bits or something, but because of the rules about alignment and padding, the whole structure is, it's this 1-bit boolean, and then it pads out.
Wow. World's most expensive bool flag, then 64 bits for it, because .NET already makes it a full byte, and then you also pad it.
Yep.
So okay,
And this
crazy.
one, 64 bits on its own. So with either of these later two are doubling the size, and so that's kind of what we expect is when we pass stuff through. Now we have to deal with passing through this double quad word, and so it looks like what is happening here is because of the rules of the stack. It gets its parameters from certain positions in the stack, so it's moving it from one position into the stack to a new one. Like if the stack is like something, and then it's something, and then it's like and then that's the call, and then we got our return address. Actually, is the return address on the stack? Anyway, let's just go with this rough thing now. And so we are a method here, and we're about to call another method that takes the same arguments. So, we might have our own stuff on the stack as well. And then we have to go and grab these and copy MultiString, and then put our own return address here. So this is, let's call it ZZZ. So the stack looks like that. So it's copying, copying into there, and that's what I suspect this is, and that's why it's moving a unaligned quad word. Is it's moving 128 bits from there to there. Makes sense?
Okay.
And
yep.
you can see that
it's popping basically.
So RSI is obviously something, but it's moving it into there, and then it's moving it to a different position, 38 higher on the stack.
It sounds like it's stack. RSI, is that not the stack index? I think you talked about that.
RSP is the stack pointer, and I'm just trying to work out what RSI is. RSI, RCX, RSI, RDX, whatever RDX was. So I'd have to think about it more.
Source index? I'm just Googling.
I'm pretty sure RSI is, in fact, I know that RSI is just a register. It doesn't have any specific meaning in this case.
Oh, I see. Yeah, just one of those funny words, right?
So that is worth thinking about, is that we're moving some extra data. We're moving an extra 64 bits around. Move, load effective address, move. There's 5 move instructions. And then it does 2 load effective addresses instead of 1 for whatever reason. Probably to DX. I'm not 100% sure why it needs to do that, but it's actually not that much. So we've got an extra move here, and we've got an extra move here, and one of these moves is like a SIMD instruction, but without bringing up the SIMD reference, you'll probably find that this is no slower instruction-wise than just a regular old move anyway. Does that make sense? So obviously these two are equivalent because we're not actually touching this data, we're just moving it around.
Right. So
every time we pass this data, we have 2 extra instructions, roughly speaking, let's say. And then let's finally go and look at internal getid. And so I'll just run to cursor here.
I hope it's better. Or otherwise this was the worst one.
Well, we hope it's better because doesn't that look promising? And so this is internal getid. And so you can see that here we were having to do a is, so we know that is like text is, no, actually text, sorry, what is it? No, this is just a return string. Have I got these backwards? I've got these backwards. My bad. I thought so. I thought I had them backwards. Anyway, so this is the second one, and this is the first one. So you can see here, yeah. Like our discussion was correct, but then I just got the two windows back to front. I'll fix that.
I feel slightly better now. It seems like we had slightly better performance in that one, in the caching version, because of the lack of branches.
Yeah.
Oh, never mind.
This makes more sense. So this is first one, second one, third one. So this is the one where we've got a boolean, and so this is just a bool return. So this is setting up the function. Like this is, you know, moving the stack pointer, moving our parameter argument registers around. So, you know, RDI, RSI, RCX, RDX. So we're pulling in whatever the parameters were. If you recall, the other day we were looking at Wikipedia about the calling convention for x64 on Microsoft, and so parameters are passed in these registers first. And then over here, we're actually doing the useful business of doing that if, you know, if that bool is true, so test, and then jump if equal. So that's calling, that's jumping to 4C, which we can scroll down here as that. So it's like if it's equal, go over to this bit of code, otherwise just fall through to here. So, and these are our two branches. And each of these branches is doing the cast, and so you've got all these jumps and calls, and it's a bit of a nightmare. Whereas in our new one, so we've got again the setup for the function. We're doing a test, but this time instead of testing a boolean for, you know, is it set or not, we're testing almost exactly the same thing. It's like, is a pointer null or not? So is a pointer 0 or not? So this is basically the same code, and we get a jump to 28. And then all of a sudden, this 28, move, call, move, pop. So this is, we're moving some arguments around, not doing anything too exciting. We're fixing up this, like the rest of this, fixing up the stack and returning, and the parameters, the registers that are saved or whatever. So this is just calling convention stuff. So all we're doing is like a move and a call. Really, maybe two moves and a call. No, a move and a call. So this, for this one, is by far the most efficient.
Although, like you said, I mean, we're trading performance with data. Like we're, you know, passing more data around, but we're getting faster.
So certainly, I would never want to do this one, because like this has the same size. So this one was basically the same, and this one is much worse, and this one is basically the same, as we discovered.
Right.
So let's just copy these in here so we can actually.
Makes sense, because I mean, like checking, you know, doing the check against a bool versus doing a check against a cache bool, like, yeah, it kind of makes sense that only added problems or made it slower.
Exactly. So up the stack again and get my disassembly for this one. So I'm just going to copy these all into here just so I can have them all lined up. So I'm going to reject this second one. So then we're going to make a final determination about what way we're going to do it. Do I have my breakpoint, please? And then this one. Okay, so you can see that's the difference in the call side, is basically nothing. So this is what we're working with. So now we need to start thinking about what actually uses more instructions. So we'll start with the call site. So we've had to add, we're clearing a thing. We've added 1, 2, 3, 4 extra moves. So we've got, what's that? 1, 2, 3, 4, 5, 6, 7, 8 moves. This has got 4 moves and a clear. So this one's quite a bit longer. But it's worth thinking about the fact that we're only doing this once every time we create it. Once we've created this object, we don't have to create it again. Mm-hmm. So the fact that this is inlined and all of that may actually be fairly inconsequential. Like over here already, you know, we're calling internal getid. Actually, was another one. Yeah, we're calling internal getid, and then we're calling draw item. And draw item also has to do this. So already this structure is happening twice.
Right.
And then it's happening here. So like this structure happens a lot more than actually the constructor happens.
Right. That makes sense.
So we have to think about, you know, this one is the less frequent. So then let's look at moving stuff around. So what we basically discovered was we've added an extra move instruction there. Mm-hmm. In fact, we'll just count them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've added effectively 2 extra move instructions.
Right, which is basically the extra 64-bit pointer in and out.
Mm-hmm.
Right. Okay.
This one is actually a little more complicated over here.
That's like filling an array with stuff. Repeat.
Yep. Yeah. So. So this is sort of this is passing stuff around as an extra 2 move instructions. So we could say that passing stuff around 2 extra move instructions is neither here nor there. That's probably not important. This, on the other hand, is a little more substantial. And so some of this will be perhaps set up by the looks. So, yeah. Hard to say. So, and then we come to this one here, and this is the thing that keeps happening all over the code. Like for every call to say item, we then have to go and do draw item, and then we've got this structure here, and then draw item, and we really should fix this because it actually shouldn't do this, but you know, it calls label, and then label does the same thing. Not to mention this constructs a multi-string.
Right.
Or does it? No, it does. It does. So we should fix that.
Yeah, it has to.
We should actually fix that. But you know, there it happens again. And then in update, well, in both cases, we're calling internal getid, which has that structure again. So this is the thing that happens all over the place. So we've got to get the data there. That's 2 extra move instructions, but then we actually have to do something with it. And that is the difference between this garbage and this less garbage.
Right. That's the cast panic happening all over the place. Yeah.
Exactly. So that's the decision we now have to make, is which one of these ones will we keep. And because it's like code that is happening sort of all over the place, and like there's different ways of calling it, and you know, we could go ahead and make like a micro optimization test for it, or we could just look at the disassembly and make a, you know, an educated guess. So which one do you reckon we should go with? What are your thoughts?
Yeah, I mean, I sometimes use a tool like benchmark.net that does micro optimization. It has the benefit of spitting out the disassembly
Oh yeah.
In a sort of like a unit test type of thing where you just run it and it gives you the deltas and the plotting and all that. But yeah, I mean, I feel like in this case we should probably, like, it makes sense to, like, because we're not actually using this in Anger like on a game or something right now. It seems like we probably good enough with going with our best guess based on what we did here. The internal getid is probably, it's probably worth doing the optimization and just go forward with that.
So so internal getid, yeah, is probably the one that happens the most, and we get the massive saving. It may be the case that you know, if our call chains were deep enough, like the extra moving stuff around and the extra construction cost would be the more expensive thing. But obviously, trying to, like, you'd have to make a lot of calls and do a lot of constructions, which is kind of, those two things balance against each other, I guess, to make up for all of these jumps and all of this code and so on.
Yeah, and probably if you have a menu that where the construction cost is outweighing that somehow, then it's probably a bad menu. It probably needs help. Like,
yeah, so,
well, you need multiple menus or
thinking about it, it is basically how many levels of, like, how many calls deep are we going, and like we're going, here's one call, two call, and then this is, like, we've already decided, you know, this is actually not ideal, we should fix it, but it's like, you know, one call, two call, three call, and then we're here. Mm-hmm. So, you know, that's where we're at. So 3 calls, what's that? That's, we said, is 2 extra move instructions, so that's a whopping 6 extra move instructions. So you can imagine it's like, all right, for each of these, you know, just pretend that this is like this much longer, like, sorry, 6. And it's like, well, okay, now we're looking at what it would actually be, relatively speaking. Which one is better? It's like, well, it's obviously this one. It's still way better than this. So we're going to go with that. And, like, again, like, I need to emphasize that this is sort of very, like, a first pass rough guess sort of situation. Like, if this was like the code, for example, for doing like some of the stuff we did on River City Ransom, where we're like looking at a buffer and trying to scan through it as fast as possible or something, then we spend more time. We actually do measurements as well, and so on, to try and get this into a sensible state. It's like looking at these, and it's like, is there anything we can remove? Like on this one, it's like, well, there's probably, you know, can we remove that? Can we remove that? And as we found out, yes, we can remove that, like by not doing the cast. So that's the situation. So let's go back into here, and we will get rid of all of the ones that we don't like. And now we have our multi-string.
Awesome.
What is worth considering is this is actually what XNA does internally, like Microsoft's XNA. Because obviously they have that same problem with their interface to spritebatch.drawString, is they have you know, they have versions of this that take a string, and they have versions of this that take a string builder. So they immediately take this and convert it to their own version of multi-string, and then do all the processing on, like, they just write the processing code once. And so they pretty much reach the same conclusion, and that is, this is the best way to do it.
Huh. Right on.
So that concludes our little exploration of disassembling things for now. So any questions before we sort of move on to another subject next time?
No, just how to what's the daily practice for that? I mean, I know I've been starting to incorporate reading disassembly into my daily work for when I was talking about like micro optimization benchmarks and so on. But like, I mean, like you said, you only know enough to be dangerous in the sense that, but you're doing, like, you use it though, like there's enough information or knowledge there that you use it in order to do proper benchmarking, at least as a guidepost. Although you might be reading IL more often than getid assembly. I'm not sure. Like, how much does it factor into in real life to optimization?
Well, so I think it probably, because I kind of have a rough idea, and the way I code sort of supports this, and I have a rough idea of what the runtime will do. I don't so much look at the IL. Certainly these days. I mean, I guess I used to because I had to learn this stuff at some point. But it's like, all right, if my IL is, I can't remember, it's like, what is it, 32 instructions, then it's going to inline if it doesn't have, particular constructs in it. But if it's more than 32 IL instructions, then it's going to generate a call unless I, have one of the newer things and turn on aggressive inlining. Like that sort of thing. What it does with like generics and if I have a generic method that takes a what does it do with a generic method that takes a value type versus a reference type and so on, like what do those things do, like runtime type questions? That's when I'd be looking at the IL. Actually, even for the generic thing, I'd probably spend more time looking at the disassembly.
Okay. I guess then if we'll switch topics, then I guess it's sort of like where to like independent study on disassembly. What's a good way to do that other than playing those cool games?
Oh yeah. Do you have go of that?
I hadn't had a go yet. But yeah,
worth trying when you got some time. Yeah. So it's a bit hard to answer that question because it's like kind of like, well, whenever you feel like it is when you go and look at it, and it's like, here, like I've got these two options for, how do I structure this thing in the best way? This is actually probably a really great case of like, let's just look at the disassembly and see what the compiler is generating for both cases.
Right.
Because obviously we're like, oh, we can stick it in an object and just test it whenever we need to. And that saves space. Like a lot of the time, everything's about reducing the amount of space taken up because you want to reduce the amount of stuff in your cache. So you can fit more stuff in there, I guess. But in this case, we're not actually storing these things to like RAM or anything. We're not making buffers or anything of them. Then the calculation may actually be different. But when we're just passing stuff around, for example, that's a great time to go and look at the disassembly for what it's actually generating. Because most of the time,
Oh, go ahead.
I was going to say most of the time cache effects dominate, but in these situations, it's more like what code gets generated.
Right, because I think that there's a maybe a misconception that like casting is free. So long as it doesn't box, but in this case, it's definitely like we can tell that that's not true at all.
Yeah, that's
from looking at the disassembly.
Not true. Like this is by no means free. Like this is what a cast looks like. It's we test if it's null, and then we jump to there and call the thing that must be the exception. It's like it's null, throw an exception, and that'll jump off to whatever part of the framework generates the casting a null exception. But then if it is, sorry, that's for C. I got that backwards. For C, that's here. So this is the exception. So it's like, all right, if it's all right. So start again. We're taking text. We're moving it into R8. We're testing if R8 is null. If it's null, we're jumping to for C, which is going to generate the exception. So it passes that stuff in and generates an exception based on the cast. Then we are moving. Okay, so this must be the type information for string, and we're comparing whatever that type information is with whatever type pointer is in R8. And this is maybe going to be a little bit faster because string is sealed. So I suspect it probably makes that particular thing, but maybe not. Anyway, we're comparing. You recall last time we drew that diagram of the like the object is here, and then the type. The first field in the object is like a hidden field that points to the runtime type identification data. So that's what this is doing. It's just comparing that first field, which is what is in R8. So R8 is the pointer. And if it's comparing that and it's wrong, don't know why that's a jump of equal, but whatever. We're jumping to for C again, and we're going to the exception handler and generating the exception. And then finally, once we've done all that, we actually call the method.
The correct, the correct stub. So ultimately, it's nothing more than a glorified switch statement, right? I mean, we're not it's not free because just because we're casting doesn't mean the runtime doesn't have to figure out what one we mean at runtime and then call the jump to the appropriate call.
Exactly.
So yeah, it's never free. In other words.
Yeah. So it cast does actual real work, and there's 2 tests involved. Whereas over here, there's our own test, which is like all this stuff, which over here was a whole is statement. So that's obviously quite complicated.
That's very cool because a lot of the time we're kind of obsessed with allocation, right? So we don't care about casts that don't box because they don't allocate, they don't create garbage. But that doesn't. I mean, there's more than one thing we have to worry about.
Yeah. So it's like once you've dealt with the allocation and the fact because the garbage collector is going to be way more instructions than all of this. Oops.
Yeah.
Once you've dealt with that, it's like, well, what else can we deal with? And yeah, so it's also worth pointing out that we're going here. This, if you recall, is text is string. So this is an is. And so what does it do? First of all, text is in, is it RDX or RCX? It's in both. So we've got it sitting in RDX, but then we go ahead and we copy it to RCX to actually calculate stuff on it. Then we test if it's null. If it's null, we have to jump, and then we have to go and test if it's this thing. And you can see we're doing this test twice.
Yeah.
So this is why, there's that classic piece of advice, and this is a path that we didn't look at either, which we could have, but then this involves complicating the rest of our code, as we discovered, and that is text string equals text as string, and then call text string. But the thing is, then it's like we also have to do if not equal null. So
and this is faster than the is.
So so this is why most of the time it's like if you're doing an is, you should do an as, because as you can see, it's doing this test twice because it's a little bit stupid. Like it should, a sane, sensible compiler might be able to combine those. Whereas in our case, because we've got to then test for null, and then make our call, and then we'd have to do a cast on the other side. Anyway, like, this actually doesn't really save us anything. Pretty sure. Like, this thing here would probably save us this double test.
Interesting. Now I'm really curious to see whether the C# 7.2's pattern matching, if they do the right thing in that case, and do the equivalent for as versus is, for the syntactic sugar that they added.
Yes. So what they can probably at least do is they can, in fact, I think you can case this, like the null test, the test. All right. You can see they go ahead and do another null test, although this is on a different branch. So I mean, that's fair enough. But you know, they could have hoisted this null test up here, or I mean, they literally have a null test here, so they could be like, well, we know that it's not null, but we never get to that. Like, it's not smart enough to do that. So certainly, yeah, when you're writing high performance code, there's not a small amount of it that isn't like just making sure the compiler's not doing something silly. And so by like, just when you get curious, you know, it's like, well, what does the disassembly for this look like? And you go and look at it, and you can vaguely start to, you know, read this. It's like, oh, it does this. Oh, it does this twice. You know, how can I restructure this so it only does it once or something?
Right.
And you start to get a feel for it. Basically, it's a feel sort of thing. Any other questions?
No, that's good.
All right. Thanks for watching, everyone, and we will see you next time.